Welcome to this lecture. My name is Mark Scythian. The date today is August 10th, 2025. So in this lecture, we're going to prove which system has the most kinetic energy. So we have on the left here a car moving at 90 miles per hour. Next is a 30-06 rifle bullet in flight, an elephant walking at 5 miles per hour, and then a cinder block falling from 500 feet altitude. So we start with the car, which has a weight of 3,950 pounds and moving at 90 miles per hour. And then, of course, the rifle grain is 150 grains mass at 3,000 feet per second. The elephant, 24,000 pounds. And then the cinder block is 55 pounds. So we should start with the cinder block because we have to calculate the velocity of the cinder block at its maximum value. So we start with the equation for kinetic energy, 1/2 mass times velocity squared. And we need to know that kinetic energy is also equal to potential energy, as this observes the conservation of energy, which states that energy cannot be created or destroyed, but only changed in form. So in this case, we'll access the gravitational potential energy equation, which is mass times gravity times height. So we start with first deriving the equations, making the kinetic energy equal to the potential energy. And so here we can actually cancel out the mass just to solve for the final velocity of the cinder block. So this becomes 1/2 v squared is equal to gh. So if we multiply 1/2 times v squared, we will then get the product of gravitational acceleration on Earth, 9.81 meters per second squared, times the height in meters. So we convert 500 feet to meters. This is 152.4 meters. So we calculate then 0.5 v squared is equal to 1495, for which we divide both sides by 0.5. This then cancels out the 0.5 on the left side. So now we have v squared is equal to 1495 divided by 0.5. So then to cancel out the square, we can get the square root of the other side. So now we have the final velocity of the cinder block, which is 54.7 meters per second, and that is negligible air resistance because of the nature of the object. So now all we have to do is solve for the kinetic energy of the cinder block falling from 500 feet altitude, having a weight of 55 pounds. So we just take the 0.5 times the mass in kilograms. So we divide the pounds mass into 2.2 to solve for 25 kilograms. And then we take the 54.7 meters per second final velocity. We square the entire value. So we calculate 37,401 joules of kinetic energy for the cinder block. Now we move on to the elephant walking at 5 miles per hour. So we convert the 5 miles per hour into feet per second. For every 15 miles per hour, there's 22 feet per second. So we calculate the elephant walking at 7.33 feet per second. We divide that into 3.28, the number of feet to a meter. So we calculate 2.2 meters per second as the elephant's velocity. And then we convert the elephant's weight in pounds to kilograms of mass. So then it's 24,000 divided into 2.2, or 10,909 kilograms. So 1/2 mass times the velocity of 2.2 meters per second, quantity squared. So we calculate a kinetic energy for the elephant of 26,400 joules. Next, we focus on the 30-06 rifle bullet in flight. It has a mass of 150 grains, so we know 1 grain is equal to a mass of 64.8 milligrams. We multiply 150 times that value. We get 9720 milligrams. We divide this into 1,000 milligrams to a gram, so we get 9.72 grams. Then we divide 9.72 grams into 1,000 grams per kilogram. So the 30-06 rifle bullet has a mass of 0.00972 kilograms. And then we convert the bullet velocity from feet per second to meters per second by dividing it into 3.28. So we calculate 914.6 meters per second velocity. So now we can calculate the kinetic energy of the bullet, and it is 4,065.4 joules. And again, we'll convert these into foot-pounds at the end of the lecture, so we carry out the same principle calculation for the car moving. We convert its miles per hour to meters per second, so 90 times 22/15 as a fraction. That yields the feet per second, then divided into 3.28, so 40.24 meters per second. So now we can calculate the kinetic energy of the car moving at 90 miles per hour with a weight of 3,950 pounds. So this becomes 1,453,689 joules. And then 1 joule is also known as 1 Newton meter. And this is the ratio of 1 over 1.36 foot-pounds. So if we just convert the 1 over 1.36 into its decimal value of 0.735, dividing 1 into 1.36, we get 1 joule is equal to 0.735 foot-pounds. So if we just take the joule value, we can quickly convert the foot-pounds equivalent to the joules kinetic energy values. So we have proven that the car moving at 90 miles per hour with a mass of 3,950 pounds has the most kinetic energy, followed by the Cinder Block falling from 500 feet altitude with a weight of 55 pounds. And then next, the Elephant walking at 5 miles per hour with a weight of 24,000 pounds. And then lastly, the 150 grain bullet traveling at 3,000 feet per second. So thank you for watching this lecture and have a great day.